In chapter 2.7, we'll be considering the graphs of modulus functions. So let us consider a simple equation, in this case y equals to modulus x, as shown over here. Now if you want to plot this graph, again we will just create a table of values, okay, and we've got all the x values that we are interested in. We want to find the corresponding y values, and take note that in this case y is simply the magnitude of x, which is the absolute value of x. So let's start with the easy ones. From x equals to 0, y will be equals to 0. When x is equals to 1, y is 1, 2, and 3. Now if you consider negative values of x, the corresponding y value, which is simply the magnitude, in this case will be 1, 2, and 3. So with this table of values, we can now plot our graph. The intention is to have an understanding of what the graph of a modulus function actually looks like. So with our y-axis and our x-axis, 1, 2, and 3, 1, 2, and 3, negative 1, negative 2, and the last one, negative 3, this being the origin. Now we see that for positive values of positive values of x, these are the points that we have. When x is 1, y is 1. When x is 2, y is 2. When x is 3, y is equals to 3. And at the origin, when x equals to 0, y is equals to 0. So we've got one more point over here. We can join these up. And it should not be a surprise to us that we will obtain a straight line. In fact, this region of the straight line has an equation, this part over here, y equals to x. It is the same straight line as y equals to x. We can continue drawing them if we want to. Okay, it stretches on forever. Now let us consider the other side where we have negative values of x. So over here, when x is negative, we see that the y values are positive because the function is given by y equals to modulus x. So all the negative values will now be changed to positive. So when x equals to negative 1, y is equals to 1. When x equals to negative 2, y is equals to 2. And when x equals to negative 3, y is this time equals to 3. So joining them up, we will get another straight line. This time it looks like this. And again it goes on and on. This part over here, the graph can also be represented by y equals to negative x. Okay, can be represented. Now, if we look at a combination of these two red lines, we say that this is the graph of y equals to modulus of x. Okay, and this is our final graph. Do we always have to plot in order to be able to sketch a graph? We don't have to. In fact, there's a relationship between this final graph and the graph of y equals to x. Now if I want to plot the graph of y equals to x with the same x values, this is what I will have. So now y equals to x. So I have negative 3, negative 2, negative 1, 0, 1, 2, and 3. Now by plotting the equation in blue, this is what I'll obtain. So here negative 1, negative 2, negative 3. in addition to the same common points over here, I now have 1 point at -1, -1, another point -2, -2, another point -3, -3. So my blue line looks like this. And what do we notice about the red lines and the blue straight line? There is half of it that is the same, specifically on the right hand side of the y-axis, and on the left hand side it is slightly different. We see that for every x value. Okay, so let's consider when x is equals to -1, modulus x gives me 1. However, y, if it is equals to x, gives me -1. Now let's consider for x equals to -2. In the blue line, we have y equals to exactly -2. But in the red one, when we want the modulus value of x, the -2 becomes +2. When x is now equals to -3, the blue graph gives me y equals to -3. But the modulus value of -3 gives me 3. We see that all these points, they are being brought upwards. And this is because we only want the magnitude. Effectively, what we are doing is to remove the negative values and we change them to become positive. So one way to look at it is, if you are told to draw the graph of y equals to modulus x, we can simply draw the graph of y equals to x, and whatever is at the bottom, whatever is below the x-axis, specifically this portion, we reflect it upwards, as though our x-axis is a mirror. So one more time, if you are told to draw the graph of y equals to modulus x, you can simply draw the graph of y equals to x. Keep the region above the x-axis. Whatever is below the x-axis, you reflect it upwards. Okay, so this is found in our textbook page 74. So some properties is that for this red line of y equals to modulus x, we say that it is symmetrical about the y-axis. Okay, or we can call it is symmetrical about the vertical line passing through the vertex. This is called a vertex. Remember, our triangle has 3 vertices, 1, 2, and 3. So one of it is simply called a vertex. You can think of it as a point. Okay, so let us go through a worked example to see how we can do this. Worked example 20. So you're told to sketch the graph of y equals to modulus 2x plus 1. We do not need to construct the table of values. So the first step, 1, sketch y equals to 2x plus 1. Simply remove the modular sign. Step number 2, reflect all negative y values to be positive y values. In other words, this is reflect everything below the x-axis upwards, because that is the function of our modulus sign. So let us start with step 1. Y equals to 2x plus 1. So we know that that's going to give us a straight line. We can also tell that it has a positive gradient, it is sloping upwards, and it will pass through the point on the y-axis, the y-intercept is 1. So this is my graph of y equals to 2x plus 1. I'm done with step 1. Take note that this over here, we need to find out this value over here on the x-intercept. So x-intercept when y equals to 0. So 0 equals to 2x plus 1. Take note I'm trying to find the x-intercept for the graph of y equals to 2x plus 1, not the modulus. So this tells me that 2x is equals to negative 1 and x equals to negative half. Okay, so this value over here is negative half. Now I'm moving on to step number 2. Reflect all the negative y values to become positive y values. So this portion is negative y. I'm going to reflect it upwards. So reflecting upwards will result in a graph looking like this. Okay, draw it properly. Okay, so now I need to remove the portion that is below the x-axis, and I can do so by erasing these parts. Most of the time we will use dotted lines instead, so we'll just erase bits of it to result in a dotted line like this. So this is my final graph of y equals to modulus 2x plus 1. So we'll just modify this. Here's our answer. Okay. Now I'll go through another question. Practice now 20, part B. Practice now 20B. So this time we're told to sketch y equals to 3 minus x modulus. Step 1 is still the same. I will sketch the graph of y equals to 3 minus x. I know it is going to slope downwards and it is going to have a y-intercept of 3. So something like this. This is x and this being y. This must be 3 and our x-intercept will be 3. So step number 2, whatever is below the x-axis must be reflected upwards. So doing that will result in this. Okay. Now one thing to take note of, because it is reflected upwards, if I want to consider, for example, when x equals to 6, when x is equals to 6, my value of y, so y equals to 3 minus 6, is supposed to give me 3. Okay, and if I want to consider the other equation, y equals to 3 minus 6 without the modulus, it is supposed to give me negative 3. What this means is that if I had extended this line downwards, this value would have been negative 3. And if I were to draw my graph of y equals to modulus of 3 minus x, it should result in a value of 3. Okay, so just check that your graph makes sense. Okay, so this is now my graph of y equals to modulus of 3 minus x after I remove the parts below the x-axis. So here y equals to modulus of 3 minus x. So this is the final answer. I'll now show you common mistakes for drawing a modulus graph like this. So here we have the graph of y equals to 3 minus x. Sometimes students, they try to reflect it upwards, but they don't do a very good job of reflecting properly. So they may end up with something like this. Okay, looks actually okay, but the scale is this time wrong. If this is 3 units, I will still use the same x coordinates. So another 3 units over here. So this gives me 6. Okay, I'm trying to draw it to scale. Now when x is equals to 6, this time you see that my y value is no longer 3. See, when x is equals to 6, my value of y for modulus should have been 3. But in this case, it is obviously more than 3. More than 3. So we say that this is a bad drawing. So even if you had done this, you still wouldn't get the correct answer. But let's take a look at this portion over here. This over here is -3. Yeah, it seems to make sense. 3 units. Now here, 3 units. There is nothing wrong with this graph. The problem lies in the reflection upwards. It is not reflected properly. Okay, so how then do we reflect properly? Now, when you do a reflection, one thing to take note of that you will learn in physics in Sec 4, if I'm not wrong, is that this angle over here, let's say this is theta, it has to be the same as this angle over here. That is called reflection. If the angles are different, then you have reflected them wrongly, and the result will be a V-shaped graph that is not symmetrical about the vertex. See these two? Not symmetrical. So it is wrong. So to correct this, we can include another point for our reference. That is, we know when x equals to 6, y should be equals to 6. Y should be equals to 3. So now we can say for certain that, yeah, this is a good sketch. So label, this is my graph of y equals to modulus 3 minus x. So you got to do practice now 20 part A yourself. Take about 5 minutes for practice now 20A. So pause the video over here. The next type of modulus graphs that we need to consider in our syllabus will be when fx is quadratic. So this is found on textbook page 75. For example, work example 21. Sketch the graph of y equals to modulus x squared plus 2x minus 3. First, recognize that this over here is quadratic. It is of the form ax squared plus bx plus c. Does the step change? No, actually the steps do not change. So our step number 1 is still the same. Sketch y equals to x squared plus 2x minus 3. So second step, reflect everything below x-axis upwards. Okay, so step number 1. We've learned how to sketch this in Emaths. It is convenient to sketch if we are able to factorize it. It is convenient to sketch if we are able to complete the square for it. So in this case, it seems like we are able to factorize it. Okay, so y so here we have y equals to x squared plus 2x minus 3. Factorize it out and you will get x minus 1, x plus 3. Okay, so the information we require to sketch a quadratic graph will be our x-intercepts, y-intercepts, turning point, line of symmetry. So I like to find the y-intercept first. When x equals to 0, y equals to -3. Okay, so this is my y-intercept. When y equals to 0, this time I'm trying to find my x-intercepts. X equals to -3 or 1. These are my x-intercepts. If I am able to get my x-intercept, I will be able to find my line of symmetry. Line of symmetry is x equals to, so it is just the average of your x-intercepts, -3 plus 1 divided by 2, which is -1. So it is a vertical line called x equals to -1. Once I have my line of symmetry, I'm able to write my whatever point, whatever turning point it is, will be x coordinate is the same, and I need to find my y coordinate. So looking at the equation, this is what I'm trying to sketch. It is a parabola opening upwards because the coefficient of x squared is over here a +1. This is a positive value. I am going to expect a minimum point. The minimum point is at -1, and the y value, in this case I will need to calculate it out. Y equals to -1 square plus 2 times of -1 minus 3. I can choose to substitute into the original equation, or you can choose to substitute into the factorized form. Doesn't make a difference. So here we have 1 minus 2 minus 3, leaving us with -4. So we say that the y coordinate will be -4. So fill in the blank over here, this will be -4. Okay, so with all this information, I can now sketch my quadratic graph. So I like to sketch the parabola first because I always find it easier to adjust my axis rather than to adjust my parabola, especially after I manage to draw a smooth parabola in the correct shape. Okay, so we know the minimum point, that is -1, -4. So the line of symmetry is x equals to -1, and this implies that my y-axis will be to the right. So suppose this is my y-axis, and keeping in mind that the y-intercept is -3. Okay, let's draw another. Okay, so this being my y-axis, this has to be my y-intercept, and according to our calculations earlier on, this value is -3. And we see that -3 is found above -4, which makes sense. Okay, so this must be -4. So with this, if this is -3 and -4 is below it, our x-axis must lie further up. So this being -3, -2, -1, 0. This should be where my x-axis is. So horizontal line. This is my x-axis. And we look the x-intercepts is known to be -3 or 1. Okay. So this must be my +1, and this must be -3. So we also want to check the scale. If this over here is -1, this should be -2. Okay, everything seems to fall in place. So this is my graph, and I label it as y equals to x squared plus 2x minus 3. So all this is done so that I can move on to step number 2. Now I want to reflect everything below the x-axis upwards. So we see that this parabola, there's a region that is found below the x-axis, and we're going to reflect it upwards. So the parts that I'm going to highlight in yellow, they remain. This one remains, this one remains. Whatever I'm going to highlight in light blue gets flipped upwards. It's So our x-axis is a mirror. Okay, so points of interest will always be the turning point. Now take a look at this. Our turning point is a minimum point, it is -1, -4. If you were to reflect it upwards, you should get a point over here, right? With the same x coordinate of -1. And can you tell me what is this value over here? The y value. Yes, it should be 4. How do we get 4? Well, if this distance over here is 4 units, that is why we have a the minimum point of -4 for the y coordinate. Then when you reflect it properly, this should also be 4 units. Okay, so this is now our turning point. So I think you can visualize what the graph is going to look like already. This point doesn't change, this point doesn't change. We're going to reflect it upwards. So this is our turning point again, and down. Let's do a better job. Oh, by the way, we see that the original y-intercept is -3. So there is another intercept over here that will be -3. So this point is also reflected upwards. So now our curve has to pass through -3 as well. Okay, I hope you'll be able to do a better job than me. Right, so this is now the bottom part reflected upwards. Let us label the turning point. This time it is -1, 4. And I've got my new y-intercept. I'm going to erase whatever is below the x-axis. And now I can include the modular sign. And this over here is my graph of y equals to modulus x squared plus 2x minus 3. Take note that I always want to see all y-intercept, all x-intercept, if any. I want to see the equation of graph. I want all the axes to be labeled. I want all turning points with coordinates labeled. So let us try practice now 21. Practice now 21. Question B. Sketch y equals to modulus of 9 minus x squared. Step number 1, I want to sketch y equals to 9 minus x squared, which is simply 3 plus x, 3 minus x. This is what I want to sketch. So we write down the x-intercept, that is when y is equals to 0. So x equals to -3 or 3. So at the back of my mind, I know that my line of symmetry is x equals to 0. Okay, so y-intercept is when x equals to 0. So that gives me 9. My line of symmetry is x equals to negative 3 plus 3 divided by 2, which is 0, and my, in this case, will be a maximum point, because this is a parabola opening upwards. Coefficient of x squared is negative. I get a parabola opening downwards, and this being my maximum point with x value 0. So maximum point is 0 when x equals to 0, y equals to 9. That is actually my y-intercept. Okay, so drawing the graph. Parabola opening downwards. Try to get it symmetrical. Have some pride in your work. Okay, now a parabola opening downwards. Label the turning point. This is 0, 9, which tells us that our line of symmetry must be x equals to 0. Now, the line of x equals to 0 is actually our y-intercept. So instead of this, we should be doing drawing this. Okay, it looks symmetrical. So this is my y-axis, and this value over here is actually 9. That is my y-intercept. That is 9. If that is 9, then my x-axis is found below it, this being negative 3, that is the x-intercepts, and this being 3. So this is now 0. And this is my graph of y equals to 9 minus x squared. I want to move on to step 2, which is to reflect everything below the x-axis upwards. So if you like, you can start to erase parts of this. And now we're going to reflect it upwards. If you find it hard to reflect and visualize, you may always fold your paper. Fold your paper along the x-axis, put it against the light, and trace out what you see. Okay? With enough practice, you will realize that the graph should look like this. Okay, and it has to be symmetrical. And this is now our graph of y equals to modulus 9 minus x squared. So some of the common mistakes will be the way you reflect it upwards. Early on, you may have noticed that instead of reflecting it this way, I reflected it this way. Okay, see the difference between the red and the black lines? Go and fold the paper and see for yourself to convince yourself what is the correct shape. Okay, it should be this. So use the remaining time to do practice now 21 question 8. Part 8. It should take you no more than 5 minutes. And these are 3 homework questions from exercise 2G. Question 3B, 4A and 4B, they are due on the 27th of Feb.